Sometimes we need to find the antiderivative of a composite function, and the following theorem is going to help us solve this problem. Let g be a function whose range is an interval I, and let f be a function that is continuous on I. If g is differentiable on its domain and capital F is an antiderivative of f on the interval I, then the integral of f of g of x times g prime of x dx equals capital F evaluated at g of x plus c. If we let u equals g of x, then according to section 3.9, the differential du will equals g prime of x times dx. So we can simplify this theorem. The integral of f of u du equals capital F of u plus c. Let's take a look at an example of how we can apply this theorem, or simply the u sub, by finding the antiderivative of this indefinite integral. The first step is to identify your u. U is inside a parenthesis, under the square root, or in the denominator of a fraction. In our case, we see the expression 2x cubed plus 5 inside a parenthesis, so we will call it our u. And the differential du will equals the derivative of 2x cubed plus 5, which is 6x squared dx. Now we substitute the expression in the original integral. 2x cubed plus 5 became u. 6x squared dx became du, and it's u to the fourth power. So this integral transformed into a very simple integral using the variable u. And the antiderivative of this integral is just u to the fifth power divided by 5 plus c. Now the last step of u sub is to change the u expression back to the original expression, 2x cubed plus 5 to the fifth power divided by 5 plus c. In the next example, again we need to locate or identify our u. And u are usually the expression inside a parenthesis under the square root in the denominator. But in this case, we have negative x squared plus 4 inside a parenthesis. So that will be our u. Do not make the mistake and choose your u to be negative x squared plus 4 quantity square, because we want our u to be as simple as possible. So next, our du will be the derivative of negative x squared plus 4, which is just negative 2x dx. So now we're ready to do the substitution. So this integral will become 2x dx is negative of du, and the bottom negative x squared plus 4 is your u, and it's u squared. So again, in order to integrate this integral, we change it to the power form, u to the negative 2 power du. And we will use a power rule. Power increased by 1, so u to the negative 1 power divided by the new power plus c. So to simplify, we get 1 over u, and the expression for u is negative x squared plus 4 plus c. Now to exercise also we call this simple integrals to our form of the expressive function. The derivative of this expression, exercise we will do is or in the denominator of a fraction. In this case, it's very easy to identify u to be sine of x. Then our du will be derivative of sine of x is cosine of x dx. Now we rewrite the integral in terms of u. Cosine of x dx will change to du, and third root of sine of x will become u to the 1/3 power. According to the fundamentals, according to the power rule, antiderivative of u to the 3rd power is u to the 4/3 power divided by the new power 4/3 plus the constant c. Again, we substitute back the expression of x and simplify. We have 3/4 times sine of x to the 4/3 power plus c as the antiderivative. Once again, we will apply u sub to integrate the function x times square root of x minus 2. It's very easy to identify the u to be x minus 2. And our du is the derivative of x, which is just 1 dx. Now when we rewrite the original expression in terms of u, you might notice there's a problem. dx will become du. Square root of x minus 2 will become u to the 1/2 power. And there's an x right here that we might not know what to do initially. However, if you take a look at the expression of u equals x minus 2, therefore u plus 2 will equal x. So we can rewrite x as u plus 2. Do not get discouraged with this expression. In order to find an antiderivative, we can just simply apply the power rule. So we will integrate term by term. We first distribute the u to the 1/2 power and get u to the 3/2 power plus u to the 1/2 power times 2 is twice u to the 1/2 power du. So we have u to the 3/2 plus 1 is 5/2 power divided by the new power 5/2 plus twice u to the 3/2 power divided by new power 3/2 plus c. Then we can rewrite everything back using the original expression and simplify. We get 2/5 times x minus 2 to the 5/2 power plus 4/3 x minus 2 to the 3/2 power plus c. The change of variable for definite integrals. If the function u equals g of x has a continuous derivative on the closed interval ab, and f is a continuous on the range of g, then the definite integral from a to b of f composed with g times g prime of x dx equals integral from ga to gb f of u du. Let's take a look at an example where we will utilize the use substitution to evaluate a definite integral. Example number 5. The temperature of an object is changing at a rate of T times T squared minus 1 to the 4th power degrees Celsius per second. Find the temperature during the first 2 seconds. We need to note that the given function is the rate of change and is in Celsius per second. The question is asking us for the temperature, and is in the unit is degrees Celsius. In order to find the temperature, we will need to integrate the rate of change T times T squared minus 1 to the 4th power with respect to T. And because the question is asking us to find the temperature for the first 2 seconds, so we will need to integrate the rate of change from the interval 0 to 2. Take a look at this integral. Now this is not notice to be T squared minus 1. Our du will equals twice T dt, and it's easy for us to apply for the u sub. However, we also need to note that when we rewrite the integral in terms of u, we will also need to change the limit of integration. Originally, we were saying about x equals 0 to t equals 2. But when we change the integration to be on the variable du, we need to find the value u from what to what. So in this case, we will need to find the upper limit u when t equals 2. And 2 squared minus 1 is 3. For the lower limit, u will equal 0 squared minus 1 equals negative 1. So we will integrate from negative 1 to 3. T squared minus 1 to the 4th power is u to the 4th power. T times dt is 1/2 du, which we can get from here. So now we simplify this integral. 1/2 integral from negative 1 to 3 u to the 4th power du, and the antiderivative of u to the 4th power is u to the 5th power divided by 5. Evaluate from negative 1 to 3. So we have 1/2 3 to the 5th power divided by 5 is 243 over 5 minus negative 1 to the 5th power is just negative 1. So the final answer would be 122 divided by 5, which is equals to 24.4 degrees Celsius.